Welcome to the world of data center innovation with the iMasons podcast, discovering the people leading our industrial revolution. My name is Romain Tranchant, and today I'm joined by Jasper de Vries, CTO at CoolGradient. Jasper has extensive knowledge of the world of machine learning and data automation. Jasper has also been optimizing mechanical and electrical infrastructure using AI and other advanced technologies, seeing the technology grow from theory to practice. In this podcast, we are exploring the impact of new AI technologies on data center optimization. Let's get right into it. Jasper, welcome to the podcast.
Yes, thank you very much. Looking forward to it.
Yeah, this is great. Such a great topic today. A lot of people talking about it, and hopefully we can demystify some of the topics and conversations we've had around AI. But before we get there, would you mind introducing yourself to our audience?
Yeah, sure. So my name is Jasper de Vries. I'm the CTO of CoolGradient. My background is pretty boring, actually. I've been working with AI, with data for over 25 years, applying it in a huge range of domains, pharmaceutics, retail, and I've been working on applying it within the mechanical and electrical infrastructure within data centers for almost 5 years now. So yeah, looking forward to discuss more about it and shed some light on some of the questions, myths, maybe even.
There's definitely some cross-pollinations happening between different industries and the use of AI. But before we go specifically on the application of AI on data centers, it'd be great to start actually mentioning what do we understand about AI? What is AI and its different form factors? Can you shed a bit of light on this?
Oh yeah. To be honest, I have a pretty pragmatic definition or use case of AI, and let me start by saying that I totally understand some of the irritation about the hype that is around AI. A lot of people just calling everything AI these days, and it's like a magic wand that solves just about any problem in the world, and that's just not true. So I totally relate to that people can be annoyed about this. Having that said, I don't like using AI in that way to solve just about any problem, whether it's within data centers, whether it's about all the problems that we have in the world. So my pragmatic definition actually comes from how it was introduced to me at university. I still remember, and actually in the back, I have it still in the with some books. We had a subject called decision support systems, and during these decision support system classes, papers that we had to write, it was all about what software, what systems are there to assist us human beings in the daily lives, in our daily jobs. And for me, the decision support systems, and back then, people were also discussing about neural networks. It's not new. It's been around ever since the 50s or so. And what was really fascinating to me is having the augmentation of machines with the human intellect, the human intuition, so to say. And especially in complex environments like data centers, for example, with complex interactions between all the mechanical and electrical equipment, between the components of all these assets. And yeah, that's what really struck me. And to me, the definition of AI is really focused on these enhancements using machine learning, so to say. And I don't mind whatever methodology we use, just as long as people do not put the AI label on everything.
That's an interesting introduction and definition of AI in practical terms. It's what is it? An engine, an IT system, a way of churning data into something new. How can we grasp it when we might not be from the IT sphere?
Yeah, that's it. Yes, that's a good question to make it a little bit more practical. What we are now using is a lot about the neural networks, so to say. That I think it's true AI, whether you want to debate it or not. It's more of like a way of machine learning, so to say. And this sort of resembles the way our brains work with nodes, so to say, and each node is some sort of a mathematical representation and with different weights. And one can train these networks, so to say, using different algorithms like backpropagation, feed-forward neural networks, or maybe recurring neural networks. It doesn't matter, just as long as it has the ability to, again, augment our knowledge. And maybe it's good to step back and where my fascination comes from. So I did my thesis in a topic that is about where the butterfly flaps its wings in Japan, causes a hurricane in South America. This complex systems theory that was really intriguing for me, and this has changed my mindset ever since. So in the past 25 years, I've been continuously, everything I see, everything I do is based on these complex interactions. The chaos theory, is behind it. And to me, AI or machine learning, better word, I think, is a way to understand complex interactions much better, more than our linear brain, right? With simple if-then-else rules. This is something that the brain can comprehend. Now we have a concept like these artificial neural networks that are able to augment our understanding of these complex systems. And to me, that's the biggest benefit. The augmentation using machine learning, complex mathematics behind it, as a way of being able to learn from the world in ways that we've never been able to do before.
So if my understanding is correct, what we tend to see in those environments is we take a lot of pre-existing data to start forecasting how our data centers but that could be applied to many areas of the industry, not just the power and cooling aspects of our data centers, to really forecast how they would behave if we were to change something. Is that the way you're applying AI and machine learning onto the world of data centers?
Yes. So there's already a lot of data in data centers available, right? There's a lot of sensors, a lot of data points available, whether it's through your BMS systems or directly from the assets themselves, and they hold a lot of contextual information, too much for us to comprehend. And using all the latest, for example, database developments, we can just collect all this data and actually activate this data. So we now have the opportunity to not only collect all the data but also to activate all the data. So we can regardless the size, regardless the amount, we can use any of this data to build a better comprehension of just about anything around us. Is it 100% correct? No, absolutely not. But there comes in, the augmentation part. And what's really striking is that, to me at least, is that, again, referring to what I started off with, the magic wand, it's not a magic wand. And each use case requires specific translations of the machine learning possibilities here And in the case of the mechanical and electrical infrastructure within data centers, this context is physics. So we simply can't just take any recurrent neural network, have all this data available. No, we also need to understand the physical context and the complex interactions between all the physical elements in this data center. And then and only then we are somehow able to grasp and understand things that we've never been able to understand before.
So a couple of words I heard you say earlier, which is really interesting, is you're talking about use cases. So it feels to me that there is different usage of different models for machine learning that gets applied in different ways or in different flavors around our facilities. Can you give us like more specific examples of either, well, hopefully all of them working, but either the areas that works better or maybe the areas where it's less suited for this kind of application of machine learning?
Yeah, so one can start simple using focusing on one particular asset like a chiller, for example, and understand how it works and expand the scope of understanding from there. Right, what I really try to do here with the team is understanding the data center, for example, from roof to room, because we all know that whatever happens in chiller number 3 eventually impacts cryo unit number 5 on floor number 2 in room number 1, right? So this is the dynamics. However, understanding the whole dynamics of a data center is really complex. So start with a small thing, expand, but always the bigger context, the roof to room approach in there. So, for example, what we have is an approach to detect anomalies. Anomaly detection is something that you can do with machine learning. However, the most interesting concept for us applying this in data centers is that you don't do the anomaly detection on a number, you do the anomaly detection on a pattern of data. So you're not comparing numbers, but you're comparing patterns in a data center. And then it becomes really interesting because comparing patterns actually allows you to identify certain things within your infrastructure that go way beyond just certain numbers. I think the whole BMS system as we use it today, it's really like, oh, we see a number like temperature, for example, and it's above a certain threshold, so an alarm gets spit out. That's all fine. But underlying patterns, why this happens, are actually much more interesting. So why not focus on monitoring, comparing, analyzing the patterns behind it in order to, for example, prevent this temperature breach from happening? We've applied this in for example, in chiller dry cooler combinations, and by monitoring all these temperature patterns in a longitudinal way. So we have data from, with 5, 6, maybe even more years. And given certain wind direction, given certain temperatures, given a certain IT load, we are able to predict a certain pattern here in the data. And whenever the pattern is different, then it highlights a potential for optimization. So using temperature, focusing on temperature patterns, for example, we were able to detect clogged filters in the chilled watering. And these filters, because they were clogged, even though they were new, sort of wasted 75 megawatt hours per month. The local ops team was like, but can be. I mean, these filters aren't scheduled for maintenance for the next 2 years or something. And nonetheless, we were able to convince them, just open them up. Even though we are monitoring these temperatures, we know it's the filters. And that's the whole beauty. They opened them up, and the filters that we told them they're clogged were clogged, and the others were not. So I think this is a great example of how to find things within your data center that they were totally unaware of, they could not believe. And we were able to identify, not because we were measuring it, but taking the derivative of patterns in the data. And that's something where machine learning really excels. Oh, sorry, you're mute. I can't hear you.
And yet again, you're still on mute. So yeah, Jasper, I've heard you mention a couple of things which I'd like you to touch base on a bit more. The first one is the necessity of data. So we know that typically if a machine such as a chiller records a set number of points, that's the number of points that the machine learning algorithm will have to do with. In your example, you give wind directions, wind speed, temperature, and so on as other inputs. Does that mean that if I want to use machine learning, I will have to also invest in capturing far more data points to get anything valuable out of it? The other aspect of it is one of objectives. You brushed on a number of use cases, one of which being anomaly detections, one of them in predictive maintenance, one of them on optimization. Can we have our cake and eat it? Literally have all of them at the same time, or do we have to be very specific around what we want to achieve with machine learning?
Yeah, good questions. Yeah, so actually, what we find out is that we have data centers with over 235,000 data points. We also have data centers with just 3,000 data points. And it's not about the number. It's yes, it's true. The more data, the more possibilities, but it's definitely not the case that it limits any amount the ROI of this data center with just 3,000 data centers was just a few weeks. So it really depends, one, on the data that you have, but also, and this is something that we're doing research with some of the universities in the Netherlands, for example, is using synthetic data generation to fill up any blanks in your data set. So using our knowledge, using physics, we are using this new technique called synthetic data generation, where we recreate data whenever the original source is missing. So we can either use this, or we can use what we call a proxy. So it's a similar data point that we have in a data set, however, not really the same. We can still use it to come up with some interesting optimizations across the full mechanical and electrical infrastructure. Getting back to what you mentioned about the maintenance, for us, it's really simple. Before you can do the optimization for a data center, you first need to make sure that the foundation is right. So any maintenance related stuff you need to take care of before you can dynamically optimize the data center inner workings, right? So, but this data center, it's almost like a living being, where the definition of optimal changes minute by minute, hour by hour. So right now the sun is not shining with me. A minute ago it was shining. So that's already a potential change in optimal settings for your whole M&E infrastructure. And taking this into account after you've settled for all the maintenance, so to say, that's what we try to achieve. So we focus on making sure that your data center has no maintenance related things that you need to fix. For example, these filters, because these filters hamper with your reliability, so to say, as a data center. Make sure that you fix this, and then we go optimizing continuously. And to be honest, and that's one of the beautiful things. So I think the first data centers we started optimizing in this way, it's like 3 years ago. And what you see is actually the value of the optimizations increase over time, because every week there's maintenance. Literally, an example we had, somebody bumping into a machine, flipping a switch without this person even noticing, but we immediately detected the impact of flipping this switch accidentally with its knee while looking at all these patterns in the data center, right? So it's a beautiful field to be in there, and especially the impact that we can make with just a single recommendation with this machine learning based optimizations.
What an amazing example to be able to demonstrate that over time, machine learning actually gets to almost help you more than you thought it would when you started. I wanted to come back on a quick point when you started defining AI and machine learning, both of them in a joint way. You said, well, the best way to describe it is the best tools or support to augment humans in their tasks. Are we getting close to a point where actually we can maybe elevate the human as a role of control as opposed to a role of actor, especially in the realm of data centers, and let machine learning fully control your set points, valve setups, optimization, like literally letting it optimize itself, and let only the humans sit back and, well, I wouldn't say take a holiday, but at least only remain a controller on top of that system?
Yeah, good question yet again. But maybe also let's not forget that we currently have systems in data centers like BMS systems that already steer the data center on a daily basis. However, a lot of these BMS features are rule-based, if then else based, right? So the people that we work with, for example, they change the pump frequency to determine how many chillers should be switched on or off. But this doesn't then not take into account, for example, the wind direction. So if we know it's a western wind, we know from practice already, or from it's like we should turn on chiller number 1. With the current BMS systems, for example, it's based on run hours. So maybe chiller 15 all the way down in the corner, which is actually going to perform worst with the northwestern direction wind, will be switched on. Well, those are very small, simple examples, but the most benefit, I think, is from this complex systems theory, where you treat the data center where you treat the data center as a complex system itself. So what you then do is not only look at chiller number 1 because of the wind direction, but you look at what chiller has the biggest impact for the rest of the data center infrastructure. This is so complex, right? I mean, we can definitely optimize one chiller ourselves, or 2 chillers, or all the chillers. But we can't optimize the whole data center, right? Look at the data center as a whole. And this is actually the promise of machine learning, I think, where the real augmentation can take place, because it has never happened before, so to say, to really look at set points from the data center as a whole perspective. Will it be able to replace humans? Well, with the amount of intelligence, possibly, but I think that's not even what we should be focused about. What we should be focused about is for example, issues that we had the Kickstart Data Center Conference here in Amsterdam a while ago, and there was this lecture that somebody said in the next 10 years, 25% of the most experienced data center people will retire. So now having the ability to augment the humans in any way possible is great news, because we are somehow able to deal with all these people leaving the domain, and still have the knowledge, and maybe even more knowledge than we currently have. And that's the most important thing. Focus on the augmentation and see where it fits best.
It's an interesting storyline, isn't it, to see the lack of people in the coming years, for all the right reasons. People have been working extremely hard on those data centers and deserve a rest after so many years, to be able to augment the next generations of technicians coming through the doors actually with those tools. Let's talk a little bit about those facilities managers, engineers, technicians that are coming through those doors. At what point do I need to consider machine learning or AI as part of my tool set? What are the indicators? What are the use cases I need to keep an eye out for? What's the starting point?
To be honest, what we learn from all of our customers, the people that we talk with on a daily basis, is that the complexity of a data center increases. For example, when you talk about the way data centers are being cooled, it used to be air cooling only, right? So I don't have to tell you, there's not now a lot of things about liquid cooling, whether it's cold plate, immersion cooling. All of these technologies are very strong in specific situations. So you end up with hybrid facilities. However, hybrid facilities are more complex to run than just air-cooled facilities. But also another point here is the legislation. So at least here in Europe, there's a lot of legislation, but also more, even in the US, I hear about federal regulation and for sure local regulation. In Germany, for example, data centers require to deliver their heat to residential areas, for example. What then happens is that originally, just 2 or 3 years ago, right, the main driver or the main focus of data centers was make sure that they keep running. Now with, for example, this sustainability regulation, it's also like, yeah, but how do we run efficiently? And now you also then have this legislation. It's about, yeah, but deliver your heat to residential areas. So there's all these optimization challenges that are really hard to do as a data center engineer, right? How do you balance all these optimizations? How do you determine this? You need to have support and enable to make sure that all the different types of cooling are being put to use in the most efficient way together, right? So there's a lot of challenges still how to scale all these. So how do you balance all these technologies? How do you balance all these optimizations and make sure that the trade-offs that are being made, even though right now the sun is shining again, that also needs to be taken into account. So the sheer size of the complexity that data centers already face today, I would say, hey, this is the perfect time to introduce, but maybe that's also because this is the stuff that I talk to on a daily basis with our customers.
Well, Jasper, I think we're just about getting out of time. Is there any way that people can reach out to you if they have any more questions or want to discuss, maybe debate, actually the value of AI in data centers?
Yeah, for sure. I'm really passionate about this topic. Also because the potential is so great, and people are still unaware. We have a lot of use cases, that I can discuss with just about anybody. How this actually works on not just cooling, not just power, but also like the water consumption, making your facilities more reliable, more resilient. And I think as a data center industry, we're facing tremendous challenges. Obviously the potential is huge with the quest to become a more AI-driven society. But the complexities and the challenges, the complexities within the domain are also real. And using the machine learning in a way that I just described with, for example, innate comprehension of physics, so much potential that if people want to discuss more, especially when you're sort of like hesitant about it, please reach out. I fully understand any questions, hesitations about it, and looking for tough conversations, so to say.
Jasper, thank you very much for your time and your knowledge being shared with us today. On that note, I wanted to, specifically, first of all, thank you for sharing that information, and hope to see all of our listeners next time. So if you too, as a listener, have any topics that you want to see discussed on this podcast, or actually want to comment and explain some of your areas of expertise, by all means, please reach out directly at romain.trunchant@imasons.org, and we'll make sure to feature you on the next iterations of this podcast. Until then, thanks very much, and we will see you all very soon.